Welcome to Sundar's lecture. This is lecture number 43, and in this lecture we are going to see AC through RC circuit, right? We have given AC source to the series RC circuits, right? So what are the topics we have seen in the previous class? See, we have taken a problem, numerical problem that is related to RL circuit, that is series RL circuit that is connected to an AC source, right? This is the problem we have taken, and we have found many things, right? Is that what is impedance, admittance, and then we have also seen what is the current, what is the voltage across the resistor, apparent power, real power, reactive power, power factor, and all those kind of things we have seen in the previous class, right? And in the power factor we have seen many methods to find the power factor values. Everything comes out to be the same value, right? So this is what we have seen in the previous class. Now in this class we are going to see AC through RC circuit. It is directly related to AC through RL circuit. Both are pretty much similar, since instead of inductance we are having the capacitance here. That's all. That is the only difference we can see here. So we know that the voltage across this resistor will be VR and the voltage across this capacitor will be VC. And what is the total voltage? That is nothing but Vm sin omega t, and we can write this expression as, how we can write this expression? V will be is equal to VR plus VC. We know this, and this can be further written. V will be is equal to, this is nothing but it is I into R, which means we have here I is a small letter, so we use that same one. So I into R plus I into XC. This is, we have already seen, right, in the previous class or before the previous class. We have seen VC can be written as I into XC, VR can be written as I into R. And also we know that V can be written as I into Z. This has to be known very clearly, so we can write like this, right? This everything will be vectors, because we are not writing this in the form of or to say J terms, that means rectangular form. We are just writing like this, right? Vectors. These are all vectors. Now, what we can do from here on, we can go for the phasor diagram. So, how can we draw the phasor diagrams? So, phasor diagrams. Phasor diagram. See, we know that now what we will do, we will take the reference phasor as I know. We have seen this one in the previous class also, we have seen. So if you are taking I as the reference phasor, I just draw this one like this. This is nothing but I phasor. So I will mark it down. So this is nothing but I phasor. Right? We know that what is the nature of VR, that means voltage across the resistance will be in phase with the current, right? We know that one. So you will get like this. It will be here, it will be nothing but, this is nothing but, this is VR. So VR is in phase with the current value. See, this is the current and this is the VR. And what happens to the VC? VC will lags the current by 90 degree. Try to understand this one. Current will leads the voltage in the capacitive circuit, right? So here I have just taken I as the reference phasor. So voltage will lags the current by 90 degree. So it will be like this. Or I can go, see, I can draw like this. It will be like this. So what is this value? So this value will be what? V. This value will be V and C. That's all, right? Now we have drawn both the phasors, right? VR and VC. Now what is the total V? See, in the vector it will be addition. Summation of VR and VC will give you the total voltage, right? So it will be like this, right? So I can draw like this. So summation of, maybe you can draw like this. and if I draw like this, it will be like this. So what is this one now? This is nothing but the total V. This is the total V value. So I will write here, this is the V value. And what is this V? V will be is equal to I into Z, which means I maybe this will be small I, right? So small I into Z. And what is this VR? VR will be is equal to small I into R. And what is this VC? VC will be is equal to small I into XC. So this is the phasor diagram. That means the total phasor diagram we have taken like this, right? Now we can derive the voltage phasor diagram separately. Simply we can go for voltage phasor diagram. So voltage phasor diagram. We have seen this one, right? The same procedure, whatever the procedure I have followed in the RL circuit, I have just followed here also, right? So this is the rectangle diagram. Just I have drawn for the voltage, right? So what is the pi value? See, I have drawn here anyhow. This is the total I and this is the total V, right? Between these two, you have pi value. So this is pi. See, I have just transferred this XC, that means this VC to here, this side. Both are same, right? That is what I have done here. So this is the voltage triangle now. So from this voltage triangle, what is the value of V? We can find like this, right? What is the value of V? We have seen these kind of things already anyhow. So V will be is equal to what? Um, Maybe V square will be by Pythagoras theorem. V square will be is equal to VR square plus VC square. And we can write like V, which is equal to square root of what we can do here. This will be I into R the whole square plus this will be I into X C the whole square. Like this you can write, and what you can do further, we can take this I commonly outside, and this will be R square plus XC square, right? We can do like this. And what is this value now? It is very simple to understand. Maybe I have written capital letter I. Please bear me because I have written here I small letter, here it is capital letter. Both are same here. Anyway. And what is this value? Simply we can say that is nothing but this is that you just related to this expression, and this will be V will be is equal to I into Z. Commonly we can say that Z will be is equal to square root of R square plus XC square. So this is the final expression of the Z value, right? With this expression, again you can go for the impedance triangle, right? This is the voltage phasor triangle diagram, and we can also this can be called as voltage triangle, and we can go for impedance triangle now. So I have just drawn the impedance triangle. See, this is the R, which means you just relate it here. This is R, this is Z, and this is nothing but XC, right? Here I have written X, but this is XC. So that is what we have done here. So see, and also we can write this one like this should be is equal to maybe VR divided by I value. And what is the Z value here? Z will be is equal to V divided by total V divided by I, and this XC can be written as VC divided by I, and this is the values. And also you can go for so many values here. So how will you write this one? Maybe Z will be is equal to R. Maybe this angle is in the negative direction. What we can write here, this will be see, this angle is in the negative 90 degree, right? This is positive 90 degree, and see, this is R and X is the negative 90 degree. This is actually 90 degree, but negative 90 degree. So what we can write here, it is simple to say that this is minus JXC. That's all. I have just written this one in the form of rectangular form, right? So this is the value of Ez. Now we can go so many parameters. We can go for so many parameters. What is cos pi here? So this is the angle, and if you are going for cos pi, what you will get? You will get R by Z. This is nothing but we have seen this as the power factor, and also you can go for tan pi. So tan pi will be is equal to, so if you are going for tan pi, it will be xc by R. This is how you can go for impedance triangle. And also you can go for the power expression, right? We will go for power expression now. So power in RC circuit. So see, power in RC circuit, how will you write V now? See, it is simple to say, that is V will be is equal to Vm sin omega t. We know this value. This is the reference value. And what is the value of I now? So I will be is equal to Im sine of, what you will get, omega t plus pi. See why I am writing this one. You go here, and see this triangle. That means if you want to go for I value, what you will get, that means Vm by R, that means Z, and it is the plus degree, because you would have seen this one in the capacitive circuit. In the capacitive circuit, you will get, for sure, it will be 90 degree. It will be 90 degree. Since we have the resistor here, we don't know the value of pi value here. Since the presence of resistor will make this value below 90 degree in the positive way, right? We have seen this one in the inductive circuit, RL circuit. We have written like minus pi. So see this, if you simplify this value, it is now, it is not necessary to again to go for power expressions like what we have did in the previous class. That means V into I. So if you simplify this one, see if I multiply this one, this means Vm, and it will be Im sine omega t will be there, and sine of, it will be omega t plus pi, right? Only difference from the RL circuit, that this omega t, there it is omega t minus pi, here it will be omega t plus pi. That's all. Sine of A plus B, what is the formula? Sine A cos B cos A sine B, and all those kind of things we can go here. So see, this is Vm Im sine of, sine omega t, and in this it will be sine of A plus B. And what is sine of A plus B? Sine A cos B plus cos A and sine B. This will be like this. And if you multiply this one, you will get Vm Im, first term. I'm just multiplying this first term. See, cos pi is there, and this will be sine square theta. So cos pi will be there, and this becomes sine square omega t. And then it will be plus. So if I multiply this term with this one, and that comes out to be Vm Im, I will write sine pi, and it will be sine omega t cos omega t. And we have seen this, right? Sine square omega t can be written as 1 minus cos 2 omega t. So this value now p can be further simplified as Vm Im by 2, cos pi is there, and this term become now 1 minus cos 2 omega t. Just you refer my previous lectures to understand this one. Now and in this will be plus, and you will get Vm Im by 2, and this will be sine pi, and you can see that it will be sine 2 omega t. So this is the first expression, and this is the second expression now, right? And this is the first and second expression we have seen, and you see we will take like this. This is the first expression, and this is the second expression. And you see, if you get 1 minus cos 2 omega t, what you will get? This will be the average value. you will get the average value for this one, and this term defaultly becomes oscillating term. That means it becomes maximum negative 0 and negative maximum, and then it will be a positive negative term. That means oscillating term, and this will be the only positive term, and this is nothing but the real power term, and this is nothing but the reactive power term. So in RC circuit, obviously you will get the reactive power terms. For sure you will get reactive power terms. So we can finally say, P will be is equal to, maybe you put root 2 into root 2 so that it becomes Vrms Irms cos pi. So this will be Vi cos pi plus this will be Vi sin pi, and these are all vectors. These are all vectors, right? And if I want to convert this vector, see, this is the cos pi term and this is the sin pi term, and if you have like this, what you can do? Simply we can write P will be is equal to Vi cos pi plus J's Vi sin pi. We have seen these type of things already. So what you can do here, so this will be the power triangle. Right? Power triangle can be drawn. So how will you get this one? So this will come like this, and again this will be like this, right? So I can write like, see, this is the total P. So this is the total P value, and this is nothing but not P anyhow. We will write it in a different way, right? Because we will write it in a different way. How we will write always? See, this is the S, that means the apparent power, and this is nothing but P, which is equal to Vi cos pi, and also we will write this as the Q, that is equal to Vi sin pi. So this is the angle pi, right? This is the 90-degree, and that is why we have gone for this plus J 90-degree. Or here you see here, because it is the negative, so we will go for this is negative also, since this is the negative. Now this is the phasor, so I have written like this. Anyhow, this angle will be negative direction in 90 degrees, so we can write like negative. So this is how the power triangle looks like for the capacitive or RC circuit, right? So we have seen many things, right? Here also you can go for apparent power, or you can go for what to say, that cos pi will be is equal to that means real power divided by apparent power. If you go for cos pi, this is the angle, so adjacent side divided by hypotenuse side. So many things we can do here also. It will result the same expressions, whatever the things we have seen in the RL circuit. So this is how RC circuit looks like. So everything will be same, but if you are going for inductive circuit, then Z value will be R minus JXC, and the capacitor, if you are going for RC network, Z value will be R minus JXC. That is the only difference you will have. So in the next class, we will take up a problem, and we will solve one problem that is related to RC network, and then we will continue to RLC circuit. So that is very important, because RLC circuit will be the final one, and the applications of RLC circuit is very high when compared to RL and RC circuits, right? So we will take up a problem in the next class, and you go through these expressions, you will get an idea, and we will see in the next class. Thank you.